this video, I'm going to show you how to work through the example code for Lab 4. In particular, this video, I'm going to look at R. I'll have a separate video where I look at SAS. Now, this is going to be the first lab assignment where we really start working with the data sets that you've seen in the notes. So for this lab, I'm going to have these videos just to help you get up and running with the code, but for future labs, you will just have the written directions. So in this video, I'm going to be using the Module 4.1 Simple Linear Regression assignment that is available on Canvas. And in particular, I'm going to be going through the steps that show you what to do in R. Now you will notice that some of these steps are labeled Your Turn, where you are going to go and write your own code. I am not going to cover those in the video. I'm just going to cover the steps where the code is given to you. Alright, so starting at step 1, the first thing that we need to do is create an R script. So right here I have opened up RStudio, and you'll see that my RStudio is blank. I don't have anything in any of the windows. If during a previous session in RStudio, at the very end of the session, if you clicked on Save Workspace, you may see some things from your last session in these windows. If that's the case, you can go ahead and delete these. To delete the ones in your global environment, you would click on the broom. And then to delete the ones in the console, you could click on Edit, Clear Console, and it will delete those out. Now the first thing I'm going to do is create an R script to save my work in. To do that, up in the upper left-hand corner, we are going to click here and select R script. And so notice that opens up a new window where I have my R script. Now if you'll remember, at the top of any R script, I always recommend that you go in and type in some comments to remind you what this script is for. And this particular script we're using for Lab 4, so I'm going to type in the Lab 4 information. Then I'm making this video on August 31st. But of course you would put in whatever date you're currently working on this lab. Alright, so the next thing we're going to do is to read in the data. In order to read in the data, you have to do what's called selecting your working directory. Now previously, when we read in data, we used the file export. This time we are just going to directly type the code. So last time when we probably not export, but imported that data set, it generated the code for us. Here in the lab, I have just given that to you. So you'll notice in the lab, and again, I'm just going to copy this over, there are these lines of code. And you'll notice first we have the comment, and then we have the set working directory. So I'm going to show you a couple different ways that you can find where this directory is. So one way that you can do this is on your computer. If you click on where you have your files stored, and so this is all the different files on my computer, you want to navigate to the folder where you have saved the data sets for this lab, and if you just kind of click off here to the side, you will notice that it populates that file path for you. Now, one thing to be very careful of is if you copy your file path over from Windows, you'll notice that in the file path, Windows uses backslashes, but R uses forward slashes, so you will have to change those over. There is another way that you can set the working directory, and I'm going to show you that as well. Down here in the bottom right-hand window, if you click on Files, and then over here on the right, you'll notice 3 horizontal dots. If you click on this, this is going to let you navigate through all of the folders on your computer. This navigation panel is not going to show you any of the files, so don't worry if it makes it look like your folders are empty. This is just navigating through the folders. This option works really well if you're on Windows or if you are on a Mac. So I'm going to navigate to where I have my files for this class stored. And so we are currently in week 4. So again, notice I don't see any of my files, just the folders. I click open, and now I have all of the files for this week. Now on mine, I'm going to cheat here just a little bit. I'd actually saved the data in week 3, so just for illustration, I'm going to have mine set for week 3. But again, just navigate to where you have yours saved. Then from here, what you can do is once you have that folder open and you can see the file, so for example, there's the ICU, here's the delinquency. If you click on more, you'll notice it says set as working directory. So you can click this. Down in the console, it will automatically run the code that you need. And then if you want to save that in your script, and you should do that, you can copy it and paste it up here. So now our working directory has been set, and R will be able to find our files. So the next thing I'm going to do is actually read in the data. I'm going to read in the delinquency data, which is saved as a CSV. So copying that piece, you'll notice I'm using the read.csv function. If we run this, the first line here, the read.csv, it brings up some information about that function if you're interested in learning about it. The second line is what actually reads in the data. And so you'll notice now my global environment, the delinquency data is listed, it has 18 observations with 2 variables. If I wanted to view that data, I would use the next lines of code. So again, I'm going to copy these over from the Word document. So this first line of code right here will help me view the data, and I can see what it looks like. The second line is going to give me a summary of the variables in the data set. So the first one is for the delinquency variable, the second one is for the IQ, and I can see the mean of delinquency is 26.58 and the mean of IQ is 103.2. And then I have some other summaries there as well. And the last thing, whenever you're working with data, it's always a really good idea to check for missing values. So here, this is a line of code that will do that. The main thing you need to know about this line of code for you to reuse it if you want to check for missing values is you would change the name of the data set to this, and then that's the only thing that you need to change. And so notice for delinquency and IQ, there are no missing values. So that is just reading in the data and doing some basic checks. So next, let's create a scatter plot and do some of the regression that we saw for simple linear regression. First thing I'm going to do is create a scatter plot. And you'll notice I'm using the plot function to do this. In the plot function, what you'll have here is one of your variables and then the other variable. So notice what we want to do here is create a scatter plot of delinquency and IQ. So let's run this. Your plot should be created down the bottom right-hand window. Now, one thing to note is if you have moved your windows around and this window is too small to make a plot, you will get an error. This is what that error will look like. So to fix that, if you ever see that error, just drag and make that larger and rerun it. So looking at the plot, notice that IQ is placed on the x-axis and delinquency index is placed on the y. So again, going back to our code, notice we have called the delinquency index variable from the delinquency data. Then we have the tilde. So the way that the plot function works is you are always going to have your y variable, tilde, and then your x variable. The other pieces here, PCH controls the point types. XLab, notice that is in quotations, is the XLab label. YLab is how you change the Y label. And main is how you change the title of the plot. Next, we could fit the model, and we do this using the LM function. So again, notice here, I still have that similar format that I did up above. Here I have the y variable tilde the x variable, but notice that I did not have to have delinquency data $ before the name. The reason for that is here in the function I have set data equal to our data set, so when it runs this function it knows to use this data set to find these variables, whereas up here I called them directly from the data set. So running this, you'll notice you don't get any output here, And the reason for that is we have set simple linear model to be an object which contains all of the information from this function. So here in a minute we'll see how to get the information from that. But first, let's redraw our scatter plot and add the regression line in. And so you'll notice the first line is exactly the same as what we had above, but I've added a second line of code, and the function I'm using is the abline function, and the argument I'm giving that function is that the object we just created. So if we run this, you'll notice we have our scatter plot, and now it has drawn the regression line in. If we want to explore that model that we created more, we can use the summary function. And so notice now the output is given down below. And this is where you're going to see things like the estimate for beta naught and the estimate for beta 1. You also get some residual information. And then down here, you get your multiple r squared, your adjusted r squared, and then some other information. Now, to calculate S and CV in R, those are not given by the summary. We actually calculate those by hand, and we can do them using this code. So S is going to be equal to, we're going to use what's called the sigma function, and then again we're going to feed it that simple linear model object that we created. So here is the value of S, and then to get the CV value we're going to use the formula for CV, and here is that value. So now, if you compare all of the values that we were able to find with your Module 2 notes, you'll find that these are the exact same values for the delinquency data that we found in Module 2. So next, we're going to go through and create some confidence intervals for the slope. To find the 95% confidence interval for the slope, we use this code, and notice again, we're using that simple linear model object that we created earlier. And here we get the confidence intervals. We get one for both the slope and for the intercept and for the slope. So the one for slope is always going to be right next to the name of that explanatory variable. And so again, if you compare this confidence interval to what we found this time in Module 3, you'll find the exact same values. We could also find R, and R squared. We could do these a couple different ways. To find R, we could use the COR, which stands for correlation function. So there's our correlation, or little r. To find R squared, we could square this value. Or we could again look at that summary of that simple linear regression model. And notice this time, if we go back up to that summary that we just saw earlier, we can see how multiple r squared is equal to 0.2253. And so that's part of that object. So I'm going to call that out by using $r squared. And you see you get the exact same value. We could also find estimation and prediction intervals. So now adding in that code. So in order to do this, the first thing that we have to do is create a new data frame that contains the values that you want to predict or estimate at. So if you go back and you look at our Module 3 notes, you'll see that one of the values we estimated at was IQ equal to 115. So I'm creating a new object called new.dat.delinquency. And I'm going to use what's called the data frame function and set IQ equal to 15. So if you were changing this for another data set, you would choose an appropriate name here. And then you would use the new variable's name and the new value you were interested in. Next, we use the predict function. To use the predict function, the first argument is going to be the name of the model we created, the name of the new data set, and then interval will either need to be confidence or prediction. So first running this one, will give us the confidence interval, and running the second will give us the prediction interval. So again, go back and compare to the Module 3 notes, and you should find that those are the exact same values. Now the last thing we're going to look at are some diagnostic plots. This first line of code, what this does is this tells R, I want you, if you're going to make some plots, I want you to put those plots in a 2x2 grid. And you might say, well, why do you want to do that? Well, to show why we want to do that, I'm actually going to run this second line first. So notice I have plot and then the name of that object that stores our linear model. And if I do that, notice nothing happened here, but down here, RStudio is telling me hit return to see the next plot. So if I hit enter, I'm going to get a bunch of plots until it's done. And in fact, I got 4 different plots, and I could toggle through them this way, but it would be nice to have them all together. So to have them all together, we run that first line of code. And so now notice we get all of those exact same plots, but they're all on one screen together, making them easier to look at. We can make this larger. And you'll notice that these are some of the plots that we talked about earlier when it came to looking at the assumptions for that simple linear regression model and looking at diagnostics. There are other ways that we can make plots too. So here is an alternative way. This is going to use a package that is called ggfortify. Now, the first time you use a package, you have to install it. So you need to run this line of code. That you only have to use this the first time you use this ever in RStudio on your computer. So you'll run this once, and then from now until you work on a different computer, you won't have to run this line of code again. So it's going to take it a minute. You'll notice some stuff happen down here because again, this is going to get installed on your computer. And then to call that package forward, we use the library function. It's going to do some more stuff. And then finally, you can use this line of code. And again, notice you get very similar plots. Now, this one does give you that normal QQ plot that we talked about, so it's slightly different than the 4 plots that we just saw. But again, these are all plots to help you check those assumptions and to see if they were actually met. All right, so that demonstrates all of the sample code that you have using the delinquency data set. The questions in the lab are now going to ask you to do the same things, but using the Happy Planet Index data set as well as the ICU data set. So you shouldn't need any additional code. You'll just need the code that is here, but you will need to go through and systematically change this. So for example, when working with the ICU data set, you're not going to read in the delinquency data, you'll read in the ICU CSV. So I probably wouldn't call this delinquency data, I'd call it ICU underscore data. And so you would call ICU underscore data. Other things is I probably wouldn't use simple linear model again because you've already used that name with the delinquency data. And so you don't want to overwrite what you did. So when you create this piece for the ICU, I might add in ICU after that. Just to remind yourself that that model you're creating is for the ICU data set. Then of course you'll have to go through and you'll have to change your variable names and anywhere that you call those data sets. But the overall structure of the code should stay pretty much the same. You're just going to change that to match that second data set.